Hi, this is Terry Scully, and I'm here to talk about, as part of our battery management training, to give an overview of the bq34110, which is a device specifically aimed at high cell count gauging and rarely discharged applications. So I'll be walking through some of the details on that. If you're interested in further detail, please feel free to visit the product folder for the bq34110. It is already in production on our website. So what I'll be walking through in this presentation is an overview of rarely discharged systems, and then going through some of the algorithms that we have for these applications, including our end of service determination algorithm, our watt-hour charge termination, and also the accumulated charge measurement. And then finally I'll review the bq34110 and also a companion part, the bq34210, which is now sampling, not quite released yet, which are both CEDV gas gauges aimed at these rarely discharged applications. Rarely discharged applications are systems where you have a battery that is normally kept fully charged and is very rarely, maybe never even discharged as part of the application. Generally it's used as a backup system. It needs to provide some minimum guaranteed battery power to a system in case the mains power fails. Examples of these systems are UPS backup systems, telematics backup systems, you have energy storage, and you also have server power backup and emergency battery power modules. The challenge for a battery in a rarely discharged system is, how do you know that the battery is still capable of providing the required backup functionality if the power goes out? This is typically done in a traditional learning sense using a maintenance cycle, where you have a very large discharge of the battery. This may be 60 to 90% of its capacity, and then you measure how much capacity you're able to discharge, and then you charge it back up and put it back in the system. That's really not very efficient. It means that if you are doing this while the system's online, your guaranteed backup capacity is very limited to what remains. What if you had a backup event right at the point when you were in the middle of a maintenance cycle, or you have to have a redundant system, or you have to take it offline and do this maintenance cycle offline? And so this is why we came up with these algorithms in the new devices that we've introduced here.